In section 3.2, we're going to learn synthetic division, the remainder theorem, and find potential zeros of polynomial functions. Let f of x and g of x be polynomials with g of x of lesser degree than f of x and g of x of degree 1 or more. There exist unique polynomials, q of x and r of x, such that f of x equals g of x times q of x plus r of x. What that essentially means is if I divide f of x by a polynomial of lesser degree, g of x, then q of x is our quotient and r of x is our remainder. Synthetic division provides an efficient process for dividing a polynomial by a binomial of the form x minus k. Synthetic division only works for binomials of the form x minus k, where k is a number. So before we do synthetic division, let's revisit long division. I have x minus 4, which is my divisor. And we're going to divide that into 3x cubed minus 2x squared plus 0x minus 150. This 0x here is known as a placeholder. It's not necessary for the problem, but it really helps us out because if the 0x was missing, our powers will not be in the correct order. We need the power to be 3, 2, 1, then a power of 0 in order for us to do long division. So generally we put a placeholder if there's any exponent that is missing. So let's try the problem. We're going to divide x minus 4 into 3x cubed. I want to figure out what do I need to multiply by x to make a 3x cubed. And that's going to be 3x squared. I need to multiply 3x squared by x to give me the 3x cubed. Then we're going to multiply that to our divisor. 3x squared times x minus 4 gives us. So let's try synthetic division. I want to guess what I need to multiply by x to produce a 3x cubed. I know I need to multiply 3x squared to x to give us 3x cubed. So we'll write 3x cubed up here, and then we'll multiply that to our divisor. 3x squared times x is 3x cubed. 3x squared times negative 4 is negative 12x squared. We're going to distribute a negative to this number, and 3x cubed minus 3x cubed, because we distribute a negative, cancels out. The negative 12x squared actually becomes a plus because of the negative, and now we can add negative 2x squared plus 12x squared. This gives us 10x squared, and I'm going to bring down the 0x. I repeat the process. And ask, x times what gives me 10x squared? Well, that's going to be 10x. And then we'll have to multiply the x by 10x and the negative 4 by 10x. 10x times x gives us 10x squared. 10x times negative 4 gives us negative 40x. I can distribute the negative now. 10x squared minus 10x squared, because we distribute a negative, cancels out. And this negative here becomes a positive because of the negative. And now we have 0x plus 40x. After we get 40x, we'll bring down the negative 150, and then we'll repeat the process. So I'm going to ask 40x. How do I get 40x? By multiplying by x? Well, I need a 40. 40 times x gives me 40x. We'll distribute the 40 to the divisor. 40 times x is 40x. 40 times negative 4 is going to give us negative 160. We subtract, don't forget the parentheses. 40x minus 40x cancels out. This becomes a plus because of the distribution. And negative 150 plus 160 just gives us 10. So this is our remainder. This is our remainder. So we're going to attach it to the end by putting plus 10 over our divisor x minus 4. Now let's look at how the synthetic division process works. Our divisor was x minus 4 from the previous problem. So instead of x minus 4 as our divisor, we're going to just use 4. We're going to take this and take the opposite sign of negative 4 and put a plus 4 here as our divisor. Instead of 3x cubed minus 2x plus 0x minus 150, we're going to make it simpler and just use the coefficients. We'll just use 3, negative 2, 0, negative 150, just the coefficients instead of this polynomial. Now, how the synthetic process works is the first thing we do with the 3 is we drop it. We bring it down. That's how we get the 3. Then we multiply the 3 times the 4. 3 times 4 gives us a 12. So I'm going to put the 12 here underneath the negative 2. So it's negative 2 plus 12 now, and we have negative 2 plus 12 gives me 10. Then I'm going to multiply 4 times 10, and that's going to give us the 40. So let's go through how the synthetic process works. We're going to first drop down the 3, and then we're going to multiply 4 times 3. 4 times 3 gives us 12, and we're going to put the 12 in the next column below our negative 2. Then we're going to add negative 2 plus 12 gives us 10, and we're going to multiply. 4 times 10 gives us 40, and we're going to drop that underneath the 0. And we're going to add 0 plus 40 gives us 40. Then we're going to multiply 4 times 40, and that gives us 160. Negative 150 plus 160 gives us 10. So this is a process that will allow us to simplify long division a shorthand. Instead of subtracting, we're actually adding because we took the opposite of negative 4 and used positive 4 instead. And instead of having our variables show up, we're just simply using the coefficients. So it's much simpler than long division. So how do we write our answer? Well, our answer is going to be 1 degree less. So we have a power of 3. So I'm going to start with a power of 2. It's always 1 degree less. So this is going to be 3x squared plus 10x plus 40. And notice how the power is in decreasing order. We have a power of 2, 1, 0. So the 10 must be our remainder. So we'll add it as 10 over our divisor, which was originally x minus 4. So we're going to have to translate from synthetic division back to our standard form for a polynomial. And again, this part of it is our quotient, and this part of it is our remainder. A word of caution: to avoid errors, use 0 as the coefficient for any missing terms, including a missing constant term when setting up division. For example, if I have x minus 7 dividing into x to the 5th plus 2x, I need to put placeholders for this because there's a lot of terms with missing powers. So instead, I will actually do x minus 7 dividing into x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 2x plus 0. So we'll need a placeholder for any power that we're missing So we'll need a coefficient of 0 for any power that we're missing from the original polynomial that we're trying to divide. So let's use synthetic division to divide 5x cubed minus 6x squared minus 28x minus 2 over x plus 2. Notice the power is 3, 2, 1, and 0, so we don't need a placeholder in this case. We're going to express x plus 2 in the form x minus k by writing it as x minus a negative 2. So we're going to take the opposite of this when we do synthetic division. So we have negative 2 here in the front of our divisor, and we're going to have 5 minus 6, negative 28, and negative 2, which was simply the coefficients of the dividend that we're trying to divide. So we're going to start by bringing down the 5. And then we're going to multiply that by negative 2. 5 times negative 2 is negative 10. And we're going to put the negative 10 under the next column, negative 6. So we're going to add now. Negative 6 minus 10 gives us negative 16. And now we're going to multiply negative 16 times negative 2, the divisor. So negative 2 times negative 16 gives us the 32. And then we're going to add. And addition gives us 4. Now I'm going to take the number 4 and we're going to multiply by negative 2. And that's going to give us the negative 8. Now we're going to add negative 2 plus negative 8 gives us negative 10. And that's going to be our remainder. Now the quotient is 5, negative 16, and the 4, but we have to translate that back to a polynomial. So what is our answer? Our answer is always 1 degree less than what we're dividing by. Since we're starting with a power of 3, I know my answer is going to have a power of 2. Here is our solution. This becomes 5x squared minus 16x plus 4. And then we're going to attach the remainder. Since this is negative, I'm going to put a subtraction symbol, negative 10 over our divisor, x plus 2. So this is our solution translated back into a polynomial with a remainder.